Welcome to the show. This video is to introduce a paper recently published in the journal Cell Regeneration, which is the official journal of the Chinese Society of Cell Biology. The title of the paper is Regeneration and Dysregulation of Hair Regeneration, aiming for clinical application. The authors are from Shenzhen University, the People's Hospital in Shenzhen, Xianya Hospital of Central South University, and the University of Southern California, Los Angeles. Hair regeneration in mice and men. Hair can regenerate whenever you pluck them out, such as you see here in mice, which is called wound-induced regeneration. Hair also cycles between actively growing and resting, called anagen and telogen, as you see here. We can easily appreciate the dramatic difference in size and length of the hair follicle in these two different phases. This is true for both mice and men. However, regeneration or natural cycling do not always go well. For instance, androgenetic alopecia, or AGA, is a situation affecting many people over the world. It was reported that about 50% of men will have AGA at the age 50. Females also have AGA, although the ratio may be lower. Another common hair disorder is alopecia areata, or AA, which affects about 2% of the population. These disorders are not lethal, but are quite annoying and thus attract much attention. So what have we learned, and what is the situation now after decades of scientific research? First, let's talk about the evolving concept of hair follicle stem cells. The stem cells of the hair follicle are located in the bulge area, an important concept developed in the 1990s, which is about 30 years ago. We would think that these stem cells are the ultimate source of cells for hair growth and regeneration, which is actually not exactly the case. First of all, it is difficult for the concept of stem cells to explain the difference in hair cycle, which is the reason why mice hair is so short and human hair can grow very long. The longest human hair being 5 meters, which sets the world record, because for most of the time mouse hair stays in resting phase, while human hair keeps growing. This is called the hair cycle clock, which remains largely unknown. After plucking the hair follicle stem cells will mostly undergo apoptosis or cell death, with the hair germ contribute to hair regeneration. The hair germ cells are not stem cells, but another population of precursor, which can then regenerate the stem cells and other parts of the follicle. Also, hair regeneration is a population event, meaning if you just pluck one hair in mice, it will not regenerate. You have to pluck certain amount of hair follicles, then regeneration will occur. This is caused by the activation of the macrophage in the dermis, which crosstalk with the skin. Finally, the key component for hair regeneration, the dermapapilla, can itself be regenerated, meaning if you remove the dermapapilla, hair regeneration still occurs with the dermapapilla regenerated from the surrounding dermis. The microenvironment of hair regeneration. Recently, much has been known on the multiple layers of regulation that control hair regeneration, such as cold temperature promotes hair regeneration, and the corticosterone from the adrenal gland inhibits hair regeneration. Dietary fat and obesity impair hair regeneration, and the immune system, including the macrophage and the T-Rex cells, have an impact on hair regeneration. The vascular system, including the blood vessel and lymphoid vessels, also regulate hair regeneration. All these factors interact with the several components in skin, forming the microenvironment that controls hair regeneration. Now, the genetics of AGA has seen rapid progress in recent years. Although the exact mechanism for AGA remains largely unknown, the big data at the population level, such as the biobank, enable genome-wide association studies, or GWAS. Many loci have been reported to be associated with hair loss. For instance, the most significant one is the androgen receptor locus, or AR. Here we listed some potential genes for this loci and their chromosome locations. We can see some are associated with the Wnt, TGF-beta, and apoptosis pathways, while others are hard to understand. AGA is known to be caused by androgen signaling, which is reported to inhibit Wnt signaling and inhibit hair growth. However, there are still many unknowns. For instance, why androgen signaling inhibits hair growth only in the scalp area, but promotes beard growth. Currently, AGA is treated with minoxidil or finasteride, which are old drugs that have been in the market for over 30 years or even longer. New development includes hair transplantation from tissue engineering, platelet-rich plasma, and stem cell therapy. So, in summary, the genetics of AGA has been examined by GWAS, with gene functions associated with the Wnt, TGF-beta, and apoptosis pathways. Yet, the functional significance for most loci remains unclear. AGA is caused by androgen signaling, yet we don't know why androgen inhibits hair growth in the upfront scalp, but promotes beard growth. AGA is currently treated by minoxidil or finasteride, and novel approaches are under development or with unclear mechanisms. The genetics of AA has also been studied by GWAS. A list of the most significant loci and associated genes include HLA-DR or MHC2 molecules, with other immune-related genes such as CTLA-4, interleukin-2, interleukin-21, interleukin-2RA, or CD25, etc. AA is an autoimmune disease, and immune cells are found to infiltrate the lower hair bulb and attack the growing hair follicle. However, the autoantigens are mostly unknown. Other than minoxidil, which promotes hair growth, recent progress in the field includes the JAK inhibitors such as baricitinib, ruxolitinib, or tofacitinib, which inhibit the immune signals. In summary, a key concept regarding AA is the immune privilege of the hair follicle. It is unclear what causes the collapse of this immune privilege. Many loci in AA are associated with immune signaling, yet the autoantigens remain mostly unknown. Novel treatment options are available which target the immune signaling. However, remission seems inevitable at this moment. Concluding remarks. Hair follicle stem cells is a sensitive model for regenerative medicine research, and has shown that temperature, dietary fat, and hormones all have an impact on hair regeneration. AGA and AA are polygenetics in origin, which makes their mechanism very complex. And the translational progress is slow because currently we are still using drugs that have been developed a long time ago. And the major hurdle in the field is the lack of appropriate animal models. I want to thank the following: My lab is supported by the National Natural Science Foundation of China and the Shenzhen University Stable Support Program. Thank you very much for attention.